We're going to talk about ratios and proportions first, because we'll need ratios and proportions to do similar figures. Okay, so a ratio is a comparison of two quantities, so numbers, and that's using division. Guys, most of the time they look like fractions, but they can be written in three ways. So you can write it as a to b, a colon b, or a over b. All of these are telling you the same thing. It's the ratio of a compared to b. Okay, so as a fraction can be expressed, or sorry, as a ratio can be expressed as a fraction, or with the word to, or with the colon. They can be reduced just like fractions can be reduced, and they're equivalent. So the ratio 32 to 18 is the same as the ratio 16 to 9. If we looked at it as a fraction, and I divided both by 2, I get 16 over 9. Yeah, so it's reduced, like a reduced fraction, and they're still the same thing. So if we took, like this classroom, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 girls. Oh, that's not going to reduce. Okay, I have 11 girls and 4 boys. I can't reduce that, but I could double it, and that's the same ratio as 22 to 8. Okay, so we look at this, and it's important to understand that ratios can be equal, because we'll use those when we're talking about proportions and proportionality. Ratios are useful for comparing things, right? All right, so let's look at who likes sports. Who likes baseball? Okay, well, they always talk about batting average, right? Okay, so when you talk about a batting average is a ratio. It's the ratio of the number of hits to the number of at-bats. It does not include walks. Okay. So if somebody had 521 at-bats and they had 181 hits, we can find their batting average. Okay. Now when you're looking at ratios, what we want to look at is it says base hits to at-bats. Okay, that means that base hits would come in front or on top. Okay, so this is going to be my numerator. And this is going to be my denominator. So to determine their batting average, I'm going to put their base hits over their at-bats. And when we take a batting average, we're going to try to get this to equal 1. Okay, so in order to do that, we divide by 521. And we're also going to divide the numerator by 521, which is going to give us a decimal as opposed to a whole number. But what we're doing is we're looking for what's called a unit ratio. And that's when the denominator is 1. Okay, and unit ratios can tell you an average, or they can tell you like price per unit. If you know you're buying stuff in bulk and you're buying like 30 pounds of, I don't know, coffee. That's a lot of coffee. That'd probably go bad real fast. But okay, you're buying 30 pounds of coffee and it's costing you like $75. You could figure out what the price per pound is by using a unit ratio. So let's not do coffee, let's do something else. Unit ratios are really good for determining what's a better deal. I've got 80 rolls of Scott for $74.99 or 36 rolls of Cottonelle for $25.69. And you might go, oh, $25.69, that's cheaper, that's a better deal. Well, maybe it is, maybe it's not. The way to find out what's a better deal is you go to the unit ratio. You find the price per roll, or if you're doing like boxes of cereal, you find the price per ounce, price per pound, and that tells you which one is actually the better deal. Well, we do 80 over 74.99, and we're going to divide both of them by 74.99. Oh, you know what? I did that upside down. Thank you for pointing that out. We want to know price per roll, so we want the rolls to be 1. So the rolls need to go on the bottom. We'll divide both by 80. Thank you. So I do 74.99 divided by 80, and I get 0.94 over 1. So 1 roll of Scott is 94 cents. If I do the Cottonelle, I have 25.69 over 36. So I divide them both by 36. And we get 71 over 1. So yes, in fact, the Cottonelle is a better price because it's only 71 cents per roll as opposed to 94 cents per roll. Sometimes that doesn't work out. Sometimes the thing that's more expensive has a per unit price that's less. And that's why you want to look at the unit price and not the overall price when you're doing like bulk shopping, because you know it might be better to spend a little bit more money now, but you get more out of it. You get more rolls for cheaper individually, and it's as opposed to a giant jar of mayonnaise. Toilet paper is not going to go bad, and you're always going to need it. All right, so extended ratios can compare 3 or more quantities instead of just 2. But because there's more than 2, you cannot write it as a fraction. These are the ratios, the only ratios that cannot be written as a fraction, but they can still be reduced. You just kind of do it sideways instead of up and down. Okay, and they're written as A colon B colon C. Okay, and they can be used to find quantities. What we have is, we have a triangle, and the angles are 5x, 3x, and 4x. So the ratio of the angles is 3x to 4x to 5x. Okay, so basically we have some value x, and the first angle is 3 times that, the second angle is 4 times that, and the third angle is 5 times that. So the ratio of the angles is a 3 to 4 to 5 ratio. Okay. Well, what do we know about the angles in a triangle? They equal 180. So we can find these by adding them together and equaling it to 180. So I'm going to have 12x is equal to 180. And then if I divide both sides by 12, x is going to be 15. So 3x will be 3 times 15. 4x will be 4 times 15. And 5x will be 5 times 15. So these are the degrees of that triangle. And you can check yourself by adding them together. And then you know that they worked. You have to do the same thing, but you're given the ratio, but you're not given the variable. So if we have a triangle has sides in a ratio of 3 to 3 to 8, and the perimeter is 392 inches, we need to find the lengths of the sides. Well, in our previous example with the angles, we had x's in there. On this one we don't, but we can put them in. 3 could be 3x, 3x, 8x. So anytime you see that extended ratio, as long as you know what they would add up to, you just throw an x in with each of the numbers. So 3 to 3 to 8 ratio is the same thing as 3x to 3x to 8x. So to solve this problem, the perimeter is just adding up all the sides together. So I'll add the sides together, set it equal to 392. 6 and 8 is 14. Divide both sides by 14. Whatever that is. So x would be 28. Okay, but we're wanting to find the lengths of the sides, not just x. So I have 3x will be 3 times 28, and 8x will be 8 times 28. So I'll have 84 and 224. So if I were to draw that triangle, obviously not proportionate, but two sides would be 84 and one side would be 224. And when you add those up, it should equal 392, your perimeter. Oops. So we can check it. And it does add up to 392, so it worked. Yeah, it should add up to the number that it should be. So if you're doing like angles, it should add up to 180 when you're done. If you're doing like perimeter, like this, should add up to what the perimeter was told. Any two ratios that are equal to one another will form a proportion. So, for example, 1/2 is equal to 3/6. That's a proportion. Or 3 to 5 is equal to 9 to 15. Okay. Typically speaking, when we talk about proportions, we use fractions. This is the most common form. We don't have to use fractions, but we can use fractions. Okay. When you have a proportion, either way you've got it written. Yeah. When you have the outside numbers, okay, these are called the extremes. And And it's easier to see when it's written not as fractions because the extremes are on the outside. But when you're talking about with fractions, you've got the top and the bottom outside. Okay, so these are extremes. And then the inside numbers are called the means. And even if it's written as fraction, you still have the means. Okay. And there's a property where you multiply if you multiply the means together and you multiply the extremes together, you get what's called a cross product. You guys have probably used those before in algebra. But if I have A over B is equal to C over D, I multiply A times D, and I multiply B times C, and I get AD and BC. These are the cross products. And the cross product property tells me that they're equal. So if you have a proportion, so you have two fractions that are equal, and you cross multiply, you get two answers or two products that are equal, cross products. If I have 2/3 and I have 16/24. Okay, I can determine if these make a proportion or not by doing the cross multiplication. And I'll have 2 times 24 and 3 times 16. Okay, this is 48, this is 48. If these are equal, then this is equal. And if I say 2 times 8 is 16, 3 times 8 is 24. So I knew that they were equal when I made them. Or I can do something like 3 over 12 and 6 over 19. Okay. If I do the cross multiplication, I get 3 times 19 and I get 6 times 12. Of course, I don't know what 3 times 19 is off the top of my head. This is 57 and this is 72. These are not equal, so this is not a proportion. Okay, so that's how you can check to see if two fractions or two ratios are equal. You do the cross products, and the cross products have to be equal in order for the proportions to be, for it to be a proportion, for the ratios to be equal. Well, this was times 2, right? But this is plus 2. So right, but if I do the cross products, I'm going to get 72 and 120. So, do you see what I mean? No, so this would not be a proportion, basically, is what's happening. If I had 6 over 10 and then I had 12, this is times 2, so this would have to be times 2, so it would have to be 20. The same. Yeah, they have to be equivalent. So, but we can use that to solve proportions. So for example, if I have some unknown number, but I know that these two things are equal, I can find out the unknown number by doing that cross multiplication. I do x times 21 and 6 times 31.5, and I know that they have to be equal in order for this to be a proportion. So 21x is going to have to be equal to 189. And then if I divide both sides by 21, I get that x is equal to 9. So then I'll know that 6/9 would be equal to 21 over 31.5. Sometimes we have a situation where you don't have just a single variable by itself. You have some expression. Okay. So you can still cross multiply though. I'm still going to multiply these across, and I'm going to have negative 4 times 2y plus 5 is equal to 6 times 7. So what I need to do is I need to distribute that negative 4. So I get negative 8y minus 20 is equal to 42. Add 20 to both sides. Negative 8y is equal to 62. Divide by negative 8. And I don't have 62 divided by 8 memorized. It's going to be negative 7.75. And so see, for this type of problem, I would have to do the algebra to find that. I'm not going to be able to figure out, what that is without it. You can also have an example where you have variables on both sides. Okay, so I have 7 over z minus 1 is equal to 9 over z plus 4. I have to cross multiply those as well. Then distribute on both sides. Okay. I could subtract 7z from both sides. And I get 28 is equal to 2z minus 9. Add 9 to both sides. And I get 37 is equal to 2z. Divide by 2. And you get that z is equal to 18.5. So, it's not always going to, when we get into like proportional polygons, they're not going to always have this nice proportionality where it's like this one polygon is twice the size of this other polygon. It could be like 16.825 times the size of the other one. It can be these really weird, not even numbers. So the cross products is going to be really important. They go out in the wild and they tag so many animals, and then they capture some more again, like sometime later, and count how many of them had tags versus how many animals they captured. Do you guys know about that? Okay, so it's natural population predictions. So what they'll do is they will capture, say, 50. What do we want to figure the population of? Like rabbits? No, rabbits are boring. How about deer? Whatever. They'll capture 50 some animals, so we'll just say there's wild donkeys.
Mexico. Or Texas. 50 wild donkeys.
Okay, fine. They capture 50 donkeys out in the woods. Okay, and then they tag them. All right? And then they release them. Okay, sometime later, they capture 50 more donkeys. And they count how many have tags. Okay? So let's say out of those 50 donkeys, 13 had tags. Okay? So what we have is 13 tagged out of 50 captured. Now, in the wild, they had tagged 50 donkeys, right? 50 wild donkeys. But yeah. Okay, so they know that they tagged 50 out of some unknown number. Well, when they captured it, they captured 50 of them and 13 were tagged. So 13 out of 50 is the ratio of tagged to untagged. Now, this is not an exact science, but it's a really good approximation of populations because it's impossible to go out in the wild and count every single animal in an area, right? Yeah, it's another good guess. No. So we can use this to predict how many wild donkeys there are in these woods. So I'm going to do 13 over 50, so that's tagged over captured, versus 50 tagged total out of the whole population. And so we're going to get 13x is equal to 50 times 50. Divide both sides by 13. Now this is not going to obviously divide evenly. That's okay, because I'll tell you what to do with that. Yeah. So here's what happens. Out of those donkeys that they tagged, they can predict, well, we get 192.307. Well, obviously you don't have 0.3 of a donkey, right? You can't have a third of a donkey floating around out there. No, it doesn't work that way. So they round to the nearest whole number. So they can say there are approximately 192 wild donkeys roaming those woods. Proportions are used for surveying. So like you might take a survey of some students in the school about, like, I don't know, favorite breakfast cereal out of a list or something. And then if you know the total number of students in the whole school, you could predict how many of those students like Frosted Flakes the best or something, So for surveys, we do population. You can do sales projections, things like that with proportions. So they can be useful for making predictions. If you have A over B is equal to B over, or C over D, well, I can flip those and make it B over A is equal to D over C. But I can also rearrange it. I can put A and C together and B and D together in a fraction. And the reason this works is because every single one of these will give me the same cross products. So you can see A times D, A times D, A times D, A times D. B times C, B times C, B times C, B times C. So they can be arranged differently. Usually this is to make things easier when you look at them. Like if you're setting up the proportions yourself. Like personally, I like to put the smallest number on top and the larger number on the bottom because that looks prettier to me. But you don't have to, because as you can see, I can put A over B or I can put B over A. As long as these two numbers always get multiplied, B and C, the arrangement can change. So that's important to know too, because that tells you there's 4 different right ways you can set these up. So you don't have to worry as much about, like, does this one have to be on top and this one has to be on the bottom? Not necessarily. Okay. The extremes have to be multiplied, and the means have to be multiplied. Other than that, the setup can be different. Okay, so for homework, I would like you guys in the packet to do page 7 and page 8 odds. Evens for extra credit. Okay?